Hello guys, so today I'm going to be going over summer 2015's question 5 solution. So it looks like for question 5, the focus of this question is going to be object-oriented programming. So what are we going to be doing today in this question? So it looks like the prompt is the TAs are building a social networking website called CS61A+, and the TAs plan to represent the network in a class called network that supports this following method. So just glancing at the skeleton code, looks like what we're going to be doing is implementing this method. So the method add friend, user1, user2, looks like it has two main goals that it tries to accomplish. So first of all, it wants to add user1 and user2 to each other's friends list. And if these users are not in the network, then we're going to add them to the dictionary of friends. So what I like to do when I start to figure out how I can implement a problem is to make a sort of little list of what I have to do in this method. So one of the things I have to do is I have to add users to each other's friend list. And secondly, if either of them is not in the network, then we're going to add them to the friends dictionary. Okay. So now that we've looked at the basic wording of this problem, let's start to look at the doc test to see if we can get any more hints of how we can implement this problem. Okay. So it looks like the first line, we are just initializing a network. So that network is going to be empty. And then notice here when we say first the add friend, the friends, the self.friends here is an empty dictionary so far. So this is showing the number 2 goal that we're going to do in the method, is that we are going to make friends right now, which is empty. It looks like friends is a dictionary where the key is the name of the user. So username, and the value of the key of this that is associated with each key is going to be a list of names. And this is going to be what friends is. And it looks like when we add multiple friends, it remembers this data, right? So friends gets updated. And we remember the friends that we did before. Okay, so now that we have the basics idea of what we're going to be doing, we can start to implement this method. So it looks like we have an if statement here, and in the wording of the question, notice that there is already an if statement. So let's see if we can highlight this. So this if here. So this if right here, it's a bad color. Let's change that to a more noticeable color. Let's do some green. Okay. Awesome. So this if statement is a keyword, because if we're going to say something in a phrase like, if we're going to do this, that automatically points us to say, okay, we're probably going to be executing or doing this sort of action within an if statement in our code. So if either user 1 or user 2 are not in the network, then we're going to add them as a key to the dictionary of friends. So what that means in code word is that we're actually in these two if statements. That means we're just going to initialize user 1 and user 2 in friends if they already do not exist. If and only if user1 / user2 not in friends. So we can just write that out. If user1 is not in self.friends, then we're going to initialize it. So we're going to say self.friends of user1 is going to be an empty list. So that's how we're going to be initializing the friends list for each user if they do not exist. And now that we've initialized user1, remember, if user2 is also not in the network, that means we also have to initialize user2's friends list. So let's go ahead and do that. So we're going to say if user2 is not in self.friends, then what are we going to do? We're going to initialize in self.friends a friend list for user2. So right now it's just going to be empty. All right, so that is already, we've accomplished the second goal of this method here. So far we've written if either is not in the network, we're going to initialize or add them to the friends dictionary. So yay, we've done that. Now we have to add users to each other's friends list. And that's going to happen whether or not they were not in the network initially, or if they are in the network initially. So how do we do that? So we know that for each user in this dictionary, the value attached to that key is going to be a list of their friends. So knowing that the dictionary stores these lists, that means that we can start using like list methods to add things to the list. So in order to do that, we can say self.friends. So we can access user one's list by using this by using this line of code. So now once we run that, that's going to give us a list, right? And so far, it doesn't matter what's in the list, but we do know that whatever's in that list, we want to add. So we want to add user2 to that list, right? So that means that we want to append user2 onto that list. And the same goes for user2's list. So for self.friends, this time user2's friend list, we want to append user1. Okay, and now we finished 5A using this sort of problem solving. And yay, we did it. Okay. All right, so moving on to 5B. So unfortunately, looks like CS61A plus is not doing so well. So to attract more users, the TAs want to implement a feature that checks if two users, so it checks if two users have at most n degrees of separation. So it can have like lower degrees of separation, but we want to check if they have at most n degrees of separation. So this is going to be our example list. So if network has this list of self.friends and it has something like this. So here are the main key points of this method that we are implementing. So by definition, there are 0 degrees of separation between a person and themselves. Okay, that's a good thing to note. And there is 1 degree of separation between Robert and Jeffrey, because if it's 1 degree, that means they're direct friends. And there are 2 degrees of separation between Robert and Yulin. And that's because the 2 degrees happen. That means that they're a friend of a friend. And for the degree of separation between Albert and anyone else, that's undefined, since Albert sadly has no friends. So how this is going to work, it looks like 0 degrees of separation. That seems to be sort of a base case here. And a base case. And why is that? It's because this is when n, so the degrees, is equal to 0. So if that's true, I'm thinking, okay, in the recursive case, that means we're probably, so in the recursive case, we're probably going to be decrementing n in order to hit this base case, right? So, yep, this sort of thinking. Also, if there's ever like some ifs and then returns, elif return, and all this stuff, it's kind of indicative that it's probably going to be a recursive question. So 0 degrees separation between a person and themselves. Well, we can utilize that sort of message by saying, okay, when do I know that I've successfully found somebody that is like a friend of them, right? If it's a direct friend, well, we know that they're direct friends because, for example, it says Robert and Jeffrey, because Jeffrey shows up in Robert's friends list and Robert shows up in Jeffrey's friends list. So we can try to check that if that is happening in order to see if we've actually hit a success. So how can we do that? How we can do that is, let's say if, for example, in this doc test, right? This case shows us a nice base case here. So if user 1 and user 2 are the same, we're just going to turn true because that's 0 degrees of separation. So we can say if user 1 is equal to user 2, well, that means we're going to return true because that means we've actually reached a case where user 1 is equal to user 2. So we've got it. We're done. Okay, elif. So what else do we have to check for? We have to check, oh, what is my failure case? So that is to do with n, because we want to check if something has at most n degrees of separation, which means that things could have more than n degrees of separation. So in elif, so this was our success. Yay. And this is going to be our failure case, or fail. So elif, we're going to do something with n here. So like I mentioned before, since our base case, we have to do something where like the degrees of separation is 0. That means that we're probably going to be decrementing n. And if it is a failure, that means that we're going to be reaching numbers that are below that what n is, right? So for the second case, the failure is if n is less than 0. We could also clean this up a little bit because since this first if statement checks if user 1 is equal to user 2, that means if it is, we've reached n equals to 0, and this case is false. So if they don't go into this case, so hypothetically n is equal to 0, but user 1 is not equal to user 2, that means that we're going to pass through this if case and go to this elif case. So that means we can also say n is less than or equal to 0. And that means that we're going to return false because we were unable to find a case where user 1 is equal to user 2 before hitting n is equal to 0. Okay, cool. So now we're going to have to do some, the actual recursive call, right? So for friend in, so what do we want to check? Well, we want to look into the friends list of either user 1 or user 2. That's going to be your decision to make. But let's just do like user 1 because it's the first one. So let's say we want to like go through each of these friends lists. So we can say for friend in self.friends, let's just do user 1 since it's just the lower number. So that means for each friend in the user 1's friend list. So if we take, for example, let's do just do the Robert Ewan example. So that means we are going to be iterating through the friends Jeffrey and Jessica in this for loop. So we're going to be going through Jeffrey and Jessica. So if something is true, then we're going to return true. So this is where we can start to do some sort of recursion, because for each friend, right, we want to check if they're friends with like another person that might be user 2, right? So that means if this person is degrees of separation is let's say, so if Jeffrey, right? Jeffrey, since Jeffrey and Jessica, they're both friends with Ewan. So that's why this returns true, right? So what that means in the context of this method is that when we call Robert and Ewan on degrees, it's going to call degrees on Jeffrey and let's say Ewan. And then afterwards, it will call degrees on Ewan and all like everything in this list, right? So if we're able to do that, that means that for this if statement, we want to say, so if we call degrees on that said friend and on user 2, because we want to compare the friends in user 1 and see if they equal user 2. But we want the degrees of separation to decrease because now we've actually, since we're looking towards the friends list, that means we've already used 1 degree of separation because we're looking at the direct friends' friend list. Okay. Cool. And if that's true, then we're going to return true for this. And if none of this works out, that means overall, we're just going to return false. Okay, and that's it for question 5 on summer 2015.